Anyways, today we are going to try and talk about PHP arrays. Let's see how good I can do about it. We are going to talk about what's good with PHP arrays, what's not so good, and what's really bad. And there are quite a few things. A little bit background about me. My name is Mahesh. I came from India, so if there is a problem with my accent, please speak up. I did my bachelor's about 3 years ago from IIT Delhi. I like to play sports, not the kind most of the Europe people like. I don't want to die. I have a blog where I post stuff. You can follow that. A little more background. I am working with Lucidchart right now. You can see the logo here. Before that, I was working with Zynga. Does anyone know about Zynga? Yep. Yeah, it's one of the big Facebook gaming companies. We had a very big, giant PHP code base, and I was working with a team which was under the control of pretty much the big guys. We were supposed to create technologies to optimize things such that they can act like plug and play for most of the games. So with the minimal amount of change in any code base, most of the code bases were similar because the base code remained the same. Create plug and play technologies, and there are some good things about PHP which allows to do that, and we'll talk about that later. Most of the things I will talk about, my knowledge comes from my time spent at Zynga. We are going to talk about arrays, so may as well start with what are arrays. I would hope everyone here knows that. Arrays, in the traditional sense, C++ is a contiguous chunk of memory. Every time you try to create an array, you call a malloc. It gives you a pointer to the start of the array. The size of the array becomes the type you're going to use in the array into the number of elements you're going to store in it. And all you have is the pointer to the start of the array, pointer to the start of the contiguous chunk of memory, and that's it. Going forward, PHP arrays. PHP arrays are not exactly arrays. They are maps. The reason they are maps is because it gives you so much flexibility to do stuff with PHP arrays. They are indexed arrays, they are associative arrays at the same time. You can have keys of multiple types. You have it ordered, so even though it's a map, if you add 5 as the first key and 1 as the second key, when you iterate through it, you always get 5 the first time and 1 the second time, even though it's a map. Any doubt about this? All we talked about on the last slide, that was the good part. There's not much. Bad. The reason PHP arrays suck, the reason most of the PHP performance goes down the drain as your code base increases, is because a lot of things in PHP depend on arrays. It's such a flexible data structure that everyone uses it. You don't even feel like that what you're doing is not going to be performant enough. You just use it because it's very flexible and you can get code churning fast. But since it's a map as a data structure itself, the worst case runtime of a map coming from data structures 101 is n square. The reason? Collisions. Hashes, maps, these sort of data structures can have collisions. And once you know about what is the hashing function, it's really easy to create the collisions. Memory usage. Oh, rehashing. The other thing is, even though it's a hash, you never realize that what is the size of the hash to start with. In PHP, it dynamically resizes the array, resizes the hash map, and increases the size of it as you need it. It does it all in the background, but there's a performance impact. The reason the performance impact does not become very visible is because it increments in level of 2s. So the size starts with 8, it goes to 16, then 32, then 64. So it's incrementally going to a very larger set, but nonetheless, it's rehashing, and rehashing is painful. If anyone has tried to implement a hash or a map by themselves, they would know that rehashing is one of the slowest steps in the whole hashing algorithm. The reason people use hash is order 1 lookup. But when you go through collisions and when you go through rehashing, things don't look that good actually on paper after that. The other thing is memory usage. So the only two properties in computer science we discuss performance is runtime and memory usage. Runtime, as we talked about, the worst case is n², and once you know the hashing strategy, you can create collisions. Memory usage in PHP is horrible. In traditional sense, when you create an array, the memory is basically the number of elements you have into size of each element. That's the memory you use, and it's very logical. In case of PHP, that's not true. And I'll try to show you why that's not true. Also in runtime, the traditional array, order of x is always order 1. Because you have the initial pointer to the initial element of the array. You know which element you are trying to access because it's always indexed. So you can directly jump to that memory location and get the element. In case of PHP, that's not true because you are using hashes. They try to make it order 1 because that's what hash does, but not always possible. Memory. The reason I call it a beast. You see this? This is the amount of memory it's going to try and store just for 4 elements. The reason it does that, again, for the flexibility, you keep the order, you make sure that it's an array, it's a hash, so even if there are collisions, you need to make sure that things are accessible, and then it stores a lot of metadata, a lot of it. Every single bucket you see, bucket 1, 2, 3, 4, these contain the data apart from the C bucket array. So there's a lot of metadata going on, and that bloats up the size. This is not exactly what PHP arrays look like. This is boiled down version. It's a subset. There is much more data which PHP array uses in the Zen layer. So it's even worse than what you see here. A few things which I would like to point out, if you guys can see at the top. Even though the number of elements are 4, every element is displayed by a bucket, by the way. Even though the number of elements are 4, the size of the array PHP uses is 8. So the bare minimum you can have in PHP is 8. You can't go lower than that. It will have a bunch of empty slots, but you need 8 elements to start with. Then you can see the next free. It keeps a pointer for the next free. What does that mean? It uses this variable to know the next time you are going to enter element in the array, what index should PHP give it? So in PHP, again, you can create an associative array, indexed array, and combined array at the same time. So let's say you started with the associative array. You said foo equals to bar, and the next element you added 1 equals to 5. What happens when you add the next element as an indexed element? Just brackets and something. That's when it uses next free. Whatever the number is in next free, it uses that to give the index to the array or to the element of the new element. And this is maintained by incrementing. So if every time you use the integer key, let's say the first element itself you insert is 5, the key is 5, the value is foo. The next free becomes 6. The reason? That's how PHP works. Once you insert 5, you can't go back unless you explicitly say 0 equals to this, 1 equals to this. Once you insert 5, the next time you are using it as an indexed array, it's going to give it the 6th. It's going to think it's the 6th element. And it will increment this counter to 7. So every next time you do it, it will get 7, 8, stuff like that. Other thing to point out, we have 4 buckets here, but in the C bucket array, you see only 2. Any idea why? I heard collisions, I'll take that. Collisions. 2 of these elements actually hash to the same key in the C array. And once you hash to the same key in a C array, or whatever your storage layer in hash, that's called a collision. What you do when you have a collision is, let's say bucket 1 and bucket 2 collided. What you do is, the index at which you are supposed to put bucket 1, you don't put bucket 1, you put a list. The list having the first element as bucket 1, the second element as bucket 2, and furthermore, you can have X number of collisions. You keep on appending to that list. After X elements, let's say you have another collision. When you try to insert at the end of that list, the insert time is you have to traverse all the elements to get to the last element. The insert time becomes n for that one element. And if you are inserting a total of n elements, the insert time can, in the worst case, be n squared. That's what we were talking about earlier. And that is why PHP arrays at time can behave very badly, and sometimes you would not understand why, because Zen layer actually takes care of everything, so it becomes very inexplicit. Collisions. When I said that if you know the hashing strategy, you can actually create collisions. You can actually make sure that instead of the C bucket, C array being uniformly occupied by elements, only one element is occupied and everything is going there. It so happens that PHP hashing function is incredibly simple. So once you get a hold of it, it's really easy to create collisions. The reason I say that is for integers, it just does mod size. So as long as you are keeping things integer at a particular, you space out your keys at a particular distance, you can very easily create collisions. And people do that in a very evil manner as well. We'll talk about that. For strings, it uses a particular hash function. It's a bitwise hash function. PHP uses this hash function. I can name it out, but it's very complicated. It's a bitwise hash function, and it's very fast. It uses it all over the code in Zen layer, not just ordered hash map to depict the arrays. But you can look it up. Nothing fancy about it. Pretty ordinary. Collisions. There is something which people like to call super colliding in PHP. What that means is if you can somehow write an input so that every single entry in the array collides. Collides means goes to the same particular index in the C array. The runtime becomes n squared, and just to add 64k elements, you take 30 seconds, which under normal duration you will take 0.1 second. After super colliding, you take 30 seconds. You can do that very easily by jumping hoops and bounds by 2 raised to the power 64 plus 2 raised to the power 64 plus 2 raised to the power 64. Add 2 raised to the power 64 such elements, and all of them will collide, every single one of them, because it's just going to mod and everything will go to the end of the list, and everything will keep on colliding. Interesting use of this particular property in PHP is for every PHP framework, a request is received, and underscore request variable, underscore post or get variable is created as an array. So every time you issue a curl request, let's say to a PHP server, it will take all the parameters being passed along in the request and try to create a mapping, an array. And then it calls it underscore request or underscore post. If you create your request properly, you can make the server super collide. And then that's a DOS attack. You make enough such requests and your site can boom. Apparently, people knew about it. That's why I know about it. And they fixed it in PHP 5.3.9. There is no way to fix it in the code, because that's how PHP array work. What they did was, in PHP there is a new setting which says max input vars, which means the maximum length of request variable or post variable or put variable can be just 1,000 by default. You can change it at your own risk, but at a level of 1,000, it's slow, but it's not incredibly slow. But if you let people make it as big as they want, you can make it super collide, and then it can be used to create a DOS attack on the server.
How do you catch with that 1,000 modifier?
PHP has a bunch of settings, obviously, like every language. In PHP, you can set this particular variable, max input vars. What that means is maximum input variables coming on every request. That can be set to whatever you want. It's defaulted to 1,000. Sorry. Yeah, I think we have bashed PHP enough in the scenario of arrays. There are a lot of things which are bad about it. We can keep on talking a lot more about it. There are some decently good things as well. If you are a decently small startup, or You have a fairly small code base. It works great, right? It's very flexible. You can do whatever you want, very snappy. You can write your code in 2 hours and it will work exceptionally great because very flexible. A lot of times it will ignore the errors for you because that's what PHP does. But as your code gets bigger and you have bigger problems to solve, you will have to come to a point that you have to start micro benchmarking. You have to find extensions which you can use in PHP. You have to find what you can do with your giant classes. Case in point, the biggest class we were using at Zynga was user class. Every time a user logged in, we fetched the user information, which was nothing. Then we fetched his level information. Particular people who were at very large levels, as in we used to call them whales, people who pay us money to play the game, and people who are going to pay you money will play all the time. Those people had a giant user object. The problem which happens every morning is everyone goes to their work, and that's the time everyone plays. And the only people who pay are mostly in this geographical area, America. So everyone who wakes up at that point in time starts playing at the same time, and your servers are host. You have to scale up twice your size every single day in the morning and then scale back down. The apparent solution is do something about your class. Do something that it does not suck. Fortunately, PHP has a lot of things which you can do to implement your custom stuff, magic functions, serialization, interfaces. You can do a lot of stuff, but what you need to know is where's the fault, what I did wrong to start with. And if you know that, the next time you actually implement anything, you can make sure that you don't implement it in a way that it's going to come and bite you at a later point in time. What I mean by this slide is find your use case. Arrays are what they are. They are implemented at the Zen layer. You can't change them. But you can find your use case. Finding your use case would mean, I'm going to use the example of Judy arrays. Raise a hand if anyone knows what Judy arrays are. Judy array is an array implementation done in a C library. It's a decently famous, not very famous because none of you guys know it, but it's a decently famous C library. It's an array implementation, associative array implementation. It's done by people who are very bright. It's a very complex piece of code base, very complex. It's optimized to the level of cache misses, cache line misses, as in till the level of hardware. So it's so optimized that the memory footprint is like 10x lower than what a PHP array would have. Runtime, exceptionally great because it's optimizing the hell out of it. But you don't always want to use it because, well, it's not giving you anything and it has constraints. What it is exceptionally good for is large data sets. If you are going in a zone of 100,000 elements in your array, you definitely don't want to use PHP arrays. If your elements are objects, definitely don't want to do that. What do you do at that point in time? Find an extension which does what you're trying to do in a better way. PHP extension. Who knows about PHP extension here? Okay, PHP extensions are something sort of a module in PHP. You can plug and play. It gives you. Any question?
No, sorry. You mean about the PECL library extension?
PECL. PECL extensions. You download a bunch of extensions from PECL. Yeah. I'm talking about those exactly. So those extensions, any extension you write in PHP, works in C layer. Most of the code in PHP is not performant because it works in PHP layer, and there are a whole lot of data structures PHP maintains to make things flexible for you. But if there comes a time in your code's life that you already know what you're up to, you know the bottlenecks of your code, and you know what you are exactly trying to achieve, and flexibility is not of utmost importance, you write extensions. Extensions it's written by very few people. They are incredibly hard to write, very less documentation is provided, but once you get it right, they are exceptionally well done because every computation happens in C layer, and C is exceptionally fast. There are a bunch of extensions you can use. APC, for example, if anyone knows APC, it's an extension. It works seamlessly well because it's just plugged into PHP. You don't even realize it's there. And that's the case with a bunch of extensions, whole lot of extensions. Every time you hit a bottleneck and you can think that this implementation will work exceptionally great if done in C, extension might be a way to think about. It's not easy to do, but it obviously and very well gives the payoff. And it does not have a lot of documentation. That's the bad part about it. So find your use case. Judy array would be a good thing to look up after you guys leave from here. It works exceptionally great on big data sets. One particular example I'm going to give, I talked about extension. I actually did not want to go into extensions. It's a different ball game altogether. There are many ways you can optimize PHP and write custom stuff into PHP, magic functions, extensions, interfaces. I'm going to talk a little bit about interfaces. It's one of the easier things to do. I'm going to talk about 3 particular interfaces here. If you implement the 3 particular interfaces which are jotted down here, you can make your data structure act like an array. You can do sets, you can do gets, you can do for each, and you can do a count on it. It will give you the exact number. And it obviously does what you want it to do because it's your object. So it has custom functions built into it, which you want it to work. But apart from that, it works like an array as well, so it's easier to code. These 3 interfaces, individually going through them, ArrayAccess gives you set and get, set, unset, get property on your object, pretty much like array has. You can do a set on it, you can do a get on it, unset, stuff like that. Iterator, once you implement iterator on your object can be accessed via for loop or for each loop. And for each is one of the most extensively used features in PHP. And I always go for each somehow instead of for, so I love this iterator interface. Countable, it just gives you one-and-one functionality. Count. You can call count on your object, and whatever property you want to return, it can give you that. As in your object might have an array whose size becomes the object size, or whatever case you want to do. Whatever you define as the size of your object, just return it from this implementation, and next time you call count on it, it will return that number. After implementing these 3 interfaces, your data structure, your object in PHP, can be pretty much accessed like an array. Once you do that with your custom object, we have done this particular case in point in Zynga, and it gives tremendous results. A particular technology called TideDB, it's an up-and-coming startup. They have not released their code yet, their product yet. But what we did was, it's an in-memory table, highly optimized, very small in size. And the way Zynga games work is a lot of people can play at the same time. It's multiplayer interface. So you can move objects in the game at the same time on the same screen. That leads to collision and a lot of complexity. These things can be highly optimized if you can run a database query on a table that, is there anything on x comma y? All you need is a Boolean. If there is something x comma y, you're out of sync with the server. Refresh your page, stuff like that. And this is a very trimmed down version of what we were doing, but case in point again, we took that particular data structure and we implemented these 3 interfaces on it. It started acting like an array. We did not have to do anything. And then we added a few custom functions, find collision, is colliding, stuff like that. All of these things were happening in n squared earlier because you had to go through x and y. Now they were happening at the C layer as fast as C does it, as far as any relational database can do it. And it reduces your response time by a big magnitude. I'm going to show you an example of, since TideDB is like I said, it's a startup and their product has not been released yet, I used SQLiteDB. It does not give anywhere near the performance TideDB does, but it's a good place to start. And I'm going to try and show you guys exactly what I said. Implement it as an array, access it like an array, and then use custom functions. Custom functions which can deliver you exactly what data you want, apart from the fact that you can actually iterate through the data structure. You sometimes don't have to. All you can do is select star where x is equals to y. I'm going to show you guys some. I'm sorry, my laptop actually was hosed up. That's why I don't have it up right now. Otherwise, it would have been a little quicker. I'm going to have a hard time. OK. This is a quick implementation I did for the concept I was just describing. It's a simple in-memory indexed array implementation using SQLite DB. What that means is, after we go through the implementation a little bit, every element you are going to insert in this so-called array is going to be backed up by SQLite DB, an in-memory instance of SQLite DB. And since it's going to be in SQLite DB, you can actually execute queries on it. So you can do select distinct usernames, select max of salary, select min of age, stuff like that. If you want to do these things in PHP, what you will do is do a for each, maintain a min counter, iterate through the whole array, and at the end of the array, whatever is the min is the min. That's order n in PHP layer. PHP is order 1 is not order 1, but in this case, everything happens in C layer. Since SQLite DB internally is implemented in C, everything happens in C layer, and it's fast. What I was saying about find your use case. We start with SQLite 3. SQLite 3 is one of the libraries which you can just plug and play in PHP. I'm going to extend SQLite 3, and I'm going to implement the 3 interfaces we talked about. Using these 3 interfaces, we are going to be able to set and get on this object like an array. We are going to be able to iterate the object like an array using the iterator interface, and countable, it's going to give you the count functionality. You can ignore a whole bunch of this. The idea behind all this function, the construct function, is the first time you create an element of this object, it will create a table for you. The table's name will always be XYZ. Who cares? It's a table. Every time you create a new instance of the array, you will have a new table. And since you're going to create a table, you need a schema of the table. That brings in a little bit of complexity, but once you're done with creating the table, it's going to work seamlessly just fine. That is going to be sort of the syntax. Only 3 things are 3 type of fields are supported: text, float, and integer. Text, real, and integer. This constraint comes from SQLite itself. They allow these fields. We allow these fields. We can't allow anything else. So the syntax, table syntax, says what is the name of the field, what is the type of the field. Using this syntax, I'm going to create table statement. That's going to happen in a private function. We are going to call that private function right here, and it will create a table for us, and it will create an instance of SQLite 3, give it to us. Going forward, we can use that instance to do inserts, to do selects, whatever you want. So as soon as you create an object of this type, you already have access to a table. Destruct, nothing fancy. A private function to convert the syntax we used for the table schema to a statement, SQL statement. These are the functions which are fancy. Offset set. Offset set is one of the functions you have to implement in order to implement ArrayAccess Interface. What it does is, it says every time someone is going to call $your array bracket equals to XYZ, this code is going to get executed. It's going to call this, and what we are going to do is, you can ignore the implementation. The idea is find that element is already there or not. If it's not there, put it. If it's there, update it, because that's what PHP does. A bunch of private functions just to facilitate stuff. Offset exists. Offset exists will give you functionality what PHP has in terms of is it there or not? Is it null or not? The element at x, y, z, or 1, 2, 3 is there or not? Offset unset, when you call unset on an array, on a particular index on an array, what happens? We have to delete, basically. By the way, in offset exist, we do a select star and see if there is something or not. Offset get the element at index I. Pretty simple stuff. These functions are the top 5 functions you see are implemented to get iterator interface. Once you implement these 5 functions, you have the ability to do a for loop, for each loop on your data structure. What it's doing is pretty simple. Rewind means go to the start of the array. Current means tell me the, given this index, tell me what the value as it is on this index. Next, what is the key of this index? What is the next key? Is it valid or not? Pretty simple stuff. Count, tell me the, in this particular case, it will be tell me the number of rows in the database, in the table. I'm caching it in ID, so I can do IDs. Otherwise, we could have done select count star. We actually do that to fill IDs. And then, this is the part I like. Execute DB query. All the functions you saw at the top were just simple interface implementations to allow easy access to a data structure you already had. You could have got all that information by executing that code multiple times at different places. It's just ease of use. The new stuff you get from here is, since it's a table, it's a database table, you can execute queries on it. You can do stuff like min, max, distinct, all that. That's what I'm trying to implement here. And all I'm taking is a query. I'm going to execute it and fetch the result, create an array, throw it back to you. This query is going to get executed in the C land because it's going to be in the SQLite DB library code, and it's going to be fast as compared to your for each and try to find the min or max. That was it, actually. That was a whole class in less than 180, actually 181 lines. With that class, you can do everything I tried to describe earlier. And these are just examples of all the things. You can do count, you can do a for, you can do a for each. And this is my favorite part. You can do stuff like this. You can find the min salary of all the people. You can find the max, age, min salary, distinct, or whatever, any query you can perceive of, implement it. The syntax can be further normalized a little bit. As you can see, I call from data underscore table. Data underscore table is something which is local to that class. I could have changed the implementation of execute DB query function to push that. But the idea, I hope you understand, is these things give you a lot more power of what you want to do over your object. And it's fast. It's very fast as compared to what you're going to do in PHP. Not saying that SQLite DB itself is fast. Don't try to use this code in production. SQLite DB starts sucking after around 1,000 elements. But what I want you to take away from here is the idea that you can create an array from your object and still preserve the property of your objects, which are very viable to you. And the normal stuff, unset, select distinct, the particular query I was talking about. Come on now. Any question in that implementation? Actually, I should ask for.
Would you replace the normal PHP arrays with SQLite or just
No. Never try to optimize something which is not broken. Never try to fix something which is not broken. Never try to optimize something which is not slow. PHP array, like I started with, is very flexible. It allows a lot of things. But then there comes a point in time in every code base when you actually have to start optimizing. When that point comes in your code base, that's when you want to look at such implementations. We did such an implementation in Zynga because just to tell the scale of Zynga, every time Zynga released a new game, we had a big bump, around 8 million users for a normal game within a few days. 8 million users is a big deal. When 8 million users are going to hit your servers, even though you have thousands of web servers, it's going to suck. So what you want is to optimize your code beforehand, because servers cost money. That's what you want to save. And that's why my team existed in Zynga. We implemented a bunch of these. We implemented a bunch of extensions as well. All of these things are a way to optimize PHP to the next level. PHP is not broken in the sense that you can't even start to work with it. It works exceptionally great. That's why people use it. But after a point in time, it just starts sucking. That's when you want to optimize it. And these are the ways which optimizes a whole lot out of it. The reason I like these is mostly because your code gets executed in the C layer instead of PHP. PHP, being flexible, is not that fast in its code. Any other question?
Have you done any benchmarking around those to compare like what your results would be with your new?
I did a
lot. With other stuff, or?
No, I did with PHP. The normal array access, it's just fine. I'm going to do a profiling presentation tomorrow. The number of calls you see in the particular implementation I did, it's a lot more, but the execution time is less. Actually, it's pretty much the same for each, but for each it's a little slower. But when you execute your custom queries, that's what shines out, because that implementation in PHP is a for loop. That implementation here is a SQL query. That's when it shines out in your use case, like I started with. Find your use case. Any other question? A bunch of references. I just want to put it out there. And that's it.